guys, we're starting the Trig unit officially. Yesterday we did a little bit of an introduction activity. Today we're really going to kick it off and actually do a little bit more of the mathematics involved. The stuff we did yesterday does do a nice job leading into it though. All those ratios you guys did where you realized they were the same in all the triangles, that's what trig is. It's all based on right triangles and it's all based on the same proportion setup in different triangles. But the big thing is you have to have the same angle. It's all about the angles. You got to have a right angle. Okay, this doesn't work for triangles that are not right triangles. And you have to use the same degree each time. Okay? Otherwise, it's not the same ratio. Right, so let's take a look at how this works first of all. How do I know these triangles are similar? All right, well, dig back in your brain a little bit. Go back to last week. What about these triangles makes them similar? There was a theorem we talked about, two-letter acronym. Why are these two triangles the same? Well, they have both a 90-degree angle, and they have a second angle that's the same. Hopefully in your brains you remembered AA similarity. That was one of the things you guys had a quiz on last week. If two triangles have two equal angles, then they're automatically similar. Well, what does that mean about their sides? We know their angles are all going to be congruent because we talked about that. What about their sides, though? Okay, well, their sides are not congruent. You can tell in the picture that they're different lengths, but they are proportional, and therefore they can be written in a fraction or a ratio form, which we did a lot of last week. Remember we said a proportion is really when you have fraction equals fraction, or two equivalent fractions, as Mr. Colt said. So let's tie this into our trig stuff. There's going to be some terms that we're going to use a lot of. We'll get to those in just a second, though. Let's harken back to last week, though, and see if we can set up some proportions. Let's figure out what sides match up with what. All right, so if I drag this off to the side, we have AB over BC. I'm obviously talking about the first triangle. That's this guy right here. All right, well, what does AB match with in the second triangle? It's kind of obvious since I color-coded it and it's oriented the same way. But AB should match with DE. BC should match with EF. Okay, just setting up a proportion is all we're doing, not making it anything super crazy. Second proportion, now we have AC over BC, in the first triangle. Well, what does that match with in the second triangle? Well, AC matches up with DF, BC matches up with EF. Same idea of a proportion. Okay, you guys are going to fill in the blanks for the last one. You have AB over AC. Off to the side, please type in the fraction that would make this proportion true. What does AB match with in the second triangle over what does AC match with? Go ahead and do that real quick. All right, should have said DE over DF. Hopefully you did do that. Let's move these guys out of the way. These purple blocks are getting in the way. So these fractions are actually kind of the building blocks of trigonometry. They actually relate to these three words here. Okay? So if you look at the triangles, they've got this funky looking little symbol that's called theta. That's that circle right here with the line in the middle of it. Same thing here, that's called theta. It's just a stand-in for an angle. It could be 30 degrees, it could be 40, 50, we just don't know. It's kind of like X, but we don't put X in for angles. We usually put Greek symbols. Why we do that, I don't know, but we usually use theta. It's a very, very common symbol. Okay, so opposite, adjacent, and hypotenuse are going to be extremely common words for us this next week to 2 weeks after spring break. They describe the angles based on theta. So like I talked about, you have to use the same angle each time. So if I'm going to use theta in this triangle, I have to use it in the second triangle as well. Okay. Well, if I look at A, B, and DE, because I said they're corresponding angles, where are they in relation to theta, our all-important angle spot? Okay, well look at AB. Is that opposite, adjacent, or is it the hypotenuse based on theta? Okay. Again, BCEF. What is that in relation to theta? Is it opposite, adjacent, or hypotenuse? Okay, so we're going to jump to the next page. and actually fill those in. It's the exact same thing we had before, just without a bunch of the words. And then we've got some fill in blanks down the bottom. All right, so let's dig into that a little bit. We've got theta here. Like I said, this is the important angle. So let's fill in our 3 words. Well, which one of those 3 is the one that you're used to the most? I would say hypotenuse. We talked about that with Pythagorean theorem. We've used that with right triangles for a really long time. So let's name that one first. Okay? Well, hypotenuse has to be the longest side, and it has to be across from the 90-degree angle. Okay? So let's figure out where that is. 90 degrees is that little corner box right here. If I go across from it, BC has to be the hypotenuse. Do the same thing in the second triangle. Should be in the same exact spot because those are matching. All right, well, cool. We got that part figured out. Okay, so now let's figure out opposite and adjacent. Okay, so based on theta, which side is opposite of theta? By the way, adjacent is just a fancy word for next to, or beside the angle. Okay, so which one's opposite of theta? Is it AB or is it AC? All right, well, if I kind of take theta and pretend like I'm shooting like a Nerf gun from it or something, I don't know. If I'm shooting something across from that angle, it's going to hit AB. That's the side that's opposite from that angle. Okay? Adjacent, I said, means next to. AC is the one that's next to theta. It doesn't have to shoot across from it or anything. It's actually part of that angle, so it has to be the adjacent one. Okay, and same thing on our other triangle. If I did the same thing with theta, shot my little Nerf gun, right across, it would hit the opposite side, and adjacent is the one that's next to it. Actually is part of the angle. Okay, so filling in the blanks, it should be pretty easy. Okay? For my first one, A, B, and D, E are both the opposite side. We just named that in the picture. B, C, and E, F, the ones in blue in my fractions, are both the hypotenuse. That's why I can make these fractions, is because they're corresponding parts. Okay? Well, what would go in the second fraction? Type that off to the side. Is it opposite, adjacent, hypotenuse? What would that fraction look like? What over what? Go ahead and do that real quick. All right, hopefully you did that. AC and DF, we both labeled as adjacent. They're the ones that are next to theta. BC and EF are both the hypotenuse again, so that goes there. Last one, kind of process of elimination. The reds again are the opposite sides, A, B, and DE, and then AC and DF are again the adjacent sides. These words are going to be so important to us. They're a huge part of the trig functions. That's why we're doing a ton of stuff with these words. Might seem a little silly right now, but it is going to play into it a lot. Okay, so let's look at the next one. Again, same idea, but theta is going to move around a little bit. It doesn't always have to be that bottom right-hand spot. It might be in the top left. The triangle might even be flipped around. Could be in the bottom left. So let's see if we can fill that in properly. First of all, figure out where your hypotenuse is. That's always your go-to first step, because that's the easy one. Okay, well, which one is the hypotenuse? The black, the yellow, or the red line? Well, like we talked about, hypotenuse is the one that's the longest, and it's across from the 90-degree angle. 90 degrees right here. My side across from that then is the hypotenuse. That's never going to change. No matter where I place theta, I could put theta here. I can move it over here, no matter what. Hypotenuse does not change. That's why I say start with that one. Opposite and adjacent are going to change, though, based on which triangle you're working with. So, in our first one, the side that's opposite from theta, remember my little Nerf gun analogy? If theta has a little Nerf gun, shoots it right across, pew! That would be the opposite side. It's shooting across from it. Okay, adjacent is the one that's next to it, the one that doesn't have to move at all. It's already part of that angle. It's the little buddy to the theta symbol, or whatever degree you're working with. So those are our 3 setups. All right, so filling in the blank, if I'm looking at the fraction AC over BC, let's fill in the appropriate words. AC, that's the yellow one, that's the adjacent one that I just labeled. BC then is the hypotenuse. So again, there's my fraction, my familiar words we've been working with. All right. The second and third triangle, you guys are going to try out. Make sure you pay attention to where your hypotenuse and your theta are. Hypotenuse is not going to change. It's in the exact same spot. But now, theta's in a new position, which means that it's not going to be the same opposite and adjacent. So if you shoot your little Nerf gun across, where's the opposite side? Okay, so you're going to do two things. Give me one fraction and tell me what AC over BA should become. Second fraction, tell me what AC over BC should become. Is it opposite, adjacent, hypotenuse? What word should go there? All right, so let's see if you were correct. All right, so AC is the opposite of theta. Okay, again, shoot my little Nerf gun. It's going to be the same thing over here because theta is still in the same spot. Shoo, there's a little Nerf gun. Adjacent is still here. Adjacent is here. And I really should have filled this in first. My bad. This is your hypotenuse. Again, it's the one across from the 90-degree angle. It is not determined by theta. Doesn't matter what theta is doing. It's always the hypotenuse across from the 90-degree. This one should have been opposite over adjacent. And this one should have been opposite over hypotenuse. So we have every combination of the words. Hypotenuse never is going to go on the top of the fraction, which is why there is no extra. Okay, these three fractions actually form our trig functions. SOHCAHTOA. You're going to watch the little video clip after everyone's done, but that is the abbreviation for all of our trig functions. Sine, cosine, and tangent. It's not sine, cos, and tan. Sine is SO, the abbreviation because O stands for opposite, and H stands for hypotenuse. So over here, which one was sine? It was this guy. Because opposite over hypotenuse would have been the sine of theta. Okay, so opposite over hypotenuse. So CAH, C-A-H, stands for adjacent over hypotenuse again. Cosine of any degree is always going to be the adjacent side over its hypotenuse. So check back over here. Which one was that one? It was this guy. This is the cosine of theta, adjacent over hypotenuse. Adjacent over hypotenuse. And last but not least, tangent. TOA stands for opposite over adjacent. ADJ for the abbreviation. So theta, or tangent of theta, is always going to be the opposite side divided by the adjacent side. And if you need a little phrase to help you remember, some old horse, which is sine opposite hypotenuse, caught a horse, cosine adjacent hypotenuse, taking oats away, tangent opposite adjacent. Again, the same letters as SOHCAHTOA, but some people don't like that because they can't remember which letters go with SOHCAHTOA. If you need some old horse caught a horse taking oats away, use the letters of all the beginning words, and that'll help you remember it as well.